Hi, welcome back to the Blue Hall. We are into the last session of the day for the challenge statements briefing. Together with me is my colleagues from LTA, Elma and Phuket. Phuket will be sharing on the particular challenge statements, train components, traceability for maintenance. We have 10 minutes for his sharing and then another 10 minutes for Q&A. Without further ado, Phuket, you have the floor.
All right. Okay. Hi, everybody. Very good afternoon. My name is Poikiet, and together with me it's Alma. We are from LTA Rolling Stock team. So basically, for today, we will pose a challenge on train maintenance traceability. So actually, just like our cars, our trains also have different parts that is being composed together. So different parts, different components. So likewise, same as our car, our trains will go through maintenance, such as corrective maintenance and also overhaul. So what is overhaul and corrective maintenance? Overhaul is a scheduled task to restore and also to maintain our train. And for corrective maintenance, it's an ad hoc task whereby if there's any issue with the train will send back to the workshop and conduct the corrective maintenance whereby they will identify and also rectify the fault. So why do we need traceability in our maintenance? It's because when train go through overhaul and corrective maintenance, components that are being dismounted from the train and components that are being mounted back to the train mostly are different. Let's say, take for example, when the train comes in to the workshop to conduct overhaul or CM work. In this instance, let's say we wanted to actually change out the bogie. So actually the red color components over here, it's called bogie. So this component, what is bogie? So actually bogie is it consists of, it's like a car chassis whereby it consists of wheel set, traction motors, brakes that allows propulsion for our trains. So usually we'll just remove the bogie and replace it with a spare bogie, or rather rotables. So as you can see over here, uh, the old bogie that's being taken out and the one that's being put back, it's a different one. So it's still boogie, just that it's a different serial number. It's like a F1 car where the car comes in, then come to a pit stop, and you just change the parts. So likewise, same as our train over here. So there will be different parts going into our trains. So once done, when the train move off, what will happen to the old boogie? Let's see what will happen. What will happen is that we'll go through another round of overhaul, whereby different parts will then change again. So the colored parts are some of the parts that they will be changing out and replacing it with a new serial numbers, or rather new parts and or overhauled parts. So from here we can see that there's a lot of different parts changing out, different serial number of parts coming into the bogie itself. Hence, we will want to have a tracking system that allows us to know instantly on the component whereabout and also the history of the installation. Since now we are at this component, this particular component, the bogie, for our further presentation, we will be using this bogie as an example. So just a short introduction on what are the processes that are being done during the bogie overhaul and CM works. So basically, the process of dismantling, such as this, dismantle of components, assemble of components, which is over here, replacing of components, replacing of the faulty, worn out components from the bogie, servicing to actually to recommission and also to refurbish of the components, inspection for possible damage, and revalidating the dimension, and cleaning, testing to recommission the bogie after completion of overhaul or CM work. Last but not least, our investigation that's only apply on the CM work. So what do we track? These are some of the examples these are some of the more commonly tracked items that we have. Mostly the single unit tracking, batch tracking, staff tracking, task record tracking. So for single unit tracking, take for example, let's say today there's a train failure, and we identify that there's a bogie failure, and it's because of the motor. But we do not know what triggered this failure. It might be the motor itself, it might be something else. So we can track back what is the history of installation for this particular motor. What train have this motor been installed before, and do that train have this same kind of issue occurs? So with this allows us to actually do more fault investigation and also fault trending. Next, for batch tracking. Let's say we have this, we identify that there's a defective batch of dampers, and some of the defective batch of dampers is already installed to our bogie. And with this, right, we need to quickly recall back and identify which bogie have been installed with this defective batch of dampers. And so we have to quickly identify and recall back to change out this defective batch to okay batch. That means the no issue batch. Right, that's for batch tracking. And for staff tracking, take for example, if the train failure and it was identified that it's a human error. So with human error, we will need to track who is the staff that actually conducted this maintenance. And once we identify it, then we will actually investigate and see what are the similar tasks that this particular staff have actually conducted on. With these, we also allow us to judge the competency of our staff, whether do he need more training or he needs something else to actually to help him in this maintenance work. Next will be the task record tracking, the tasks and also the records. So for this tracking, right, we'll be tracking on what are the tasks being done onto our bogie, or rather the component itself, and also what are the records, meaning the test records, the measurements that are done on the particular components. What are those? So we track down all the records that we have, so that this allows us to actually assist on the fault investigation and trending for possible predictive maintenance. All right, so having said, for our current practice, what are we doing now? As you can see over here, is an example of manual record, word records we have. So basically, this is just one example. What will happen is our staff, our ground staff, will actually after finishing their work, they will manually record down onto these particular word records, such as what have they done, what are the measurements that they have did onto the components, who is the one who did it at this column, who is the one who verified, who is the one who acknowledged, and whether the conducted maintenance, is it a pass or a fail. So after the ground staff manually record it down onto the word record, this word record, right, will be sent to a documentation room or office. Then from there, the documentation, the third party will actually start keying in all these records manually into a system called SAP. Okay, so it's manually key in using the records that are being done by the ground staff over here. So with this current practice, we got our own challenges. So what are the challenges? The challenges that we face with this current practice is that difficulty to actually retrieve past records and also to conduct trending studies. Manually written records may be lost if it's not properly stored. Multiple handling may also cause the loss of records. Time consuming for our ground staff to actually manually record while focusing on the task on hand. The need to digitalize the manual records. Wrong records may be registered during digitalizing, because if we have a non-experienced staff doing the records or for the SAP, he might not know what's going on at the maintenance site, which is the ground. Then he might record down the wrong item at the wrong columns, or rather, he might also miss out the record that he's supposed to type it in. We would like to challenge all of you on the proposed solution. And these are some of our expectations that we have. For the first three, it's quite straightforward, so I will not touch so much on it. But for the last one, simple, convenient, intuitive, for our ground staff user, considering their working environment and tasks on hand. For this point, right, I would like to further elaborate more. For our staff for our ground staff, there are also aging staff, like older staff over there. So it is important to be the system is important, or rather the process system and the software. It's important to be simple and convenient for them to use, so that they won't find hassle to actually, hey, I need to get used to a new stuff and it's very complicated for me. Yep. So okay, yep, correct. This is our expectation for the proposed solution. And with this, I end my presentation. Thank you very much. So if you have question, please do let us know. Do you expect to replace paper with digital tabs? For this, yes, because with paper, right, there will be a need to actually digitalize it into the system. So there will be a transferring of information whereby we will go to a second party, then the second party will actually key in. So there might have possibility of losing of records. That's why we are actually expecting of this digital platform.
Yeah, there is a question there about the mobile phone application. Let's say which language to have priority. English will be the one priority. That will be the main working language in Singapore. So English will be the one. There is a question: do you work with SAP? Yes, and also other platforms. But for this one, we can start off with SAP. And there is also a question on barcode, each component, and scan with the barcode scanner. Possible. It was one of the idea, but however, on the train environment, things may get dirty, especially those underframe components. So yes, a barcode is one of the possible solution. But also we are exploring if there is any further like barcode part 2 blockchain or even any other solutions. The main thing is it has to be durable and easily implementable on a dirty and tough working environment, and something that is very easy to do. Yes, barcode would be one of the potential solution. There is one question on blockchain-based solution or centralized. If that is cost-effective and easily implementable, that will be part of the consideration as well. Main thing is actually one main criteria is user friendliness, that the ground staff must be able to adapt to it easily, because they cannot, even they are more on the technician level and aging population, they may not be very familiar with something that is very high tech. So the easier to implement, the more user friendly, the better it is. The back end, we are expecting something that is simpler, because the idea is we want to make it scalable also. Once we have something working, and there is the older line in Singapore may work with one or even more depots. That's why we want to make it more scalable. Okay, PK, about the phone available ground staff, do they have smartphone or
Basically, for the ground staff, the youngest one will have the smartphone. For the older ones, they might not have those smartphone.
Solution provided might need to take into account some staff who does not have smartphone. Automate data collection with customized sensor, not so much on customized sensor, I would say, because we have so many trains. Like in one line, we may have more than 100 trains. So customized sensor may not be the preferred solution. It's something that along digitization and digitalization to automate the processes accordingly. There is a question there on the unique ID for each component for tracking. So it depends on the components. Some components may have serial number, and some have parts number and serial number. The parts number is typical to a certain type of parts, whereas the more advanced part, but not all parts, will have a serial number tracked to it. Possible if those parts have parts and serial number, they can theoretically can be detected by a camera. Yes, that is one possibility. But on top of that, then certain AI or image recognition will be required to be able to capture and record accordingly. Yes, that is possible. There is, for most of the parts, there will be IDs, but may not be all are unique, because those more commonly used parts may only have a batch number.
Yeah, like those consumables. Yes, I believe camera-based solution is feasible if it can. Yeah, I think if it's able to recognize the parts, I think it's feasible.
Also, on top of that, we had, if you recall on the presentation, There are some parts about single part tracking, multiple part tracking, also about process tracking, and also people tracking. So the parts may be resolved by that, but don't forget about the people part and also about the process as well. So yes, it can be part of the solution for camera-based solution.
So there's another question on how many components in total do you keep estimated?
Estimated.
A lot in terms of
Really a lot.
thousands and tens of thousands.
Yeah.
Yeah. In tens of thousands, I would say.
At this point, I just want to bring up that after the Q&A, you can continue to so-called mingle in the virtual space of Blue Hall to talk to our challenge statement owners or to catch any of one of us to just find out more about the challenge or anything else.
Yep. For the predictive maintenance, we are interested in predictive maintenance as well, because with predictive maintenance, right, we are able to cut down the amount of resources to actually put into the maintenance portion. So yeah, the interval can be lengthened between the maintenance.
For the email address to ask any questions later on, please forward it to mobility@padang.co. That's our main address, email address where we will be receiving all your questions and answer from accordingly. Thank you.
So just add on a bit on the predictive maintenance. That will be the next part why we want this digitalization effort to kick in, but it's not the main priority for this, what we are looking for now. That will be the advantage that we can reap off once we go embark on this digitalization journey. Are all parts ID recorded somewhere? Yes, there are certain parts ID being recorded as part of the SAP when it's being purchased, but the thing is that will be the first part of the recording, and it's not yet the where it's installed on the train, like what PK explained, is where we want to. That's where the paper form currently is being used for. So we want to see how we can digitalize this process.
I think for the questions regarding Puiki's email, please send it forward to mobility@padang.co. We will forward your email accordingly to the relevant stakeholders. Yeah, not just for Puiki, like for everybody that is involved in the SMC.
Data for data analysis, maybe you can elaborate further. What is the data that you require here?
Lim Chun elaborated on how he's looking for data that can support predictive maintenance.
So far, we are not embarking so much on that data for predictive maintenance. So unfortunately, that on that part may not be that. We don't have that kind of granularity for predictive maintenance as mentioned, because it's more what we did so far is only digitization of the forms, not so much on the digitalization of all this effort here.
I think we can take around one or two more questions. So from Hak Ching, the question is there currently a process for taking out the parts from the warehouse?
Yes, there is a process to take out parts. So firstly, the requester, that's the requester and the one who receiving it. So the requester will actually need to request for the parts to be taken, then wait for approval. Once approved, then they can actually go to the warehouse to collect it, and they will the warehouse personnel will actually record it down what is being taken out from the warehouse.
Oh, sorry, Elma, if I may add on the predictive maintenance data, my guess is, although they are the experts, I am just adding on. I guess we have those data in that sense that you will know that when the part break, there definitely somebody who record it on the physical paper form or some sort of maintenance records. But if you are saying that to use it as a digital record, maybe that I think is the part that is probably a gap or maybe a challenge here. Because of course we will know when it was changed, but it is probably in some physical hard record copies rather than a digital where I snap a finger and then I punch some keys and I can get the figure out in that sense.
Yeah, you're absolutely right, Darren. So in the sense that, yes, we know when this part fails. For example, we have one damper fail, then it's quite easy to know when is this damper failed. But the challenging part is when is this damper last being replaced. That is always the tricky part. We have to see manually when is it being replaced, and because it's not sorted by damper installation itself. So it's very difficult. We know, yes, which damper is consumed where, but if we want to do the other way around, like when is this damper on train 1 being installed, that is a tricky part. So we need to manually sieve out what are the maintenance on damper on train 1 and see where is exactly the relevant maintenance being done. So yeah, that's to answer the two questions. So for predictive, so far we not for this purpose. There are some other predictive maintenance effort ongoing within LTA and operator for on the other spectrum, but that is not within our main purview for now.
Okay, thank you, Pui Kiat and Elma, for speaking over here. After this, there will be a networking session where Elma and Pui Kiat and the other challenge owners will be hanging around in the room. So feel free to just message them in chat and then hop into one of the tables where you can have a more private discussion as to how you can collaborate together. But that will be it for our presentation over here. Thank you so much for sticking around.
Thank you.